Okay, hello everyone. So today we're going to be still focusing on geometry and we're going to be looking at finding missing angles, okay? That's our main aim for today. So our learning intentions are I'll be able to define parallel lines and perpendicular lines, and I will be able to set up algebraic equations to solve for missing angles. Okay, so first thing is parallel lines. So as it says here, parallel lines are lines that never meet. This means they're always the same distance from each other. So we've got two lines here, and as you can see, line P is going like this, and it will keep on going, and line Q is going like this. And as they keep going like this, they're never going to meet, okay? There's not going to be a bend because lines wouldn't have bends in them. So they're just going to keep going like this. They'll never meet, and because of that, they are parallel. So it says here, the line P is parallel to the line Q. And this can be written as P line Q. Okay, so that's, if you ever see this symbol, that means parallel to. So it might be useful to take this bit down into your copy. And also this definition. Then it says here, lines that are parallel to each other have arrows on them to show they are parallel. So if you're ever doing a question and you see something like this, where there's two lines and two arrows, that means that the lines are parallel. Okay? So that's what parallel lines are. Think of train tracks, okay? Those tracks are never going to meet the two tracks that the train travels on, okay? They would be examples of parallel lines. Okay, so now we're going to have a look at perpendicular lines. So perpendicular lines are lines that are at right angles or 90 degrees to each other. So again, let's have a look at the picture. You have a line M that's going down like this, and then a line L that's going across, okay? And we have an angle here of 90 degrees, or a right angle, okay? And then because we have this right angle, we know that the line M and the line L are perpendicular, okay? And it says here the line M is perpendicular to the line L. This can be written L and then this symbol here, M, okay? So that's what this symbol here means, that the line L is perpendicular to the line M, okay? Okay, so there's just one other thing that you should know about perpendicular lines. So when we say two lines are perpendicular, or when we're drawing two lines that are perpendicular, we use this symbol here, okay? Just like that. And you can draw it like that, or like that, okay? So they're the symbols that we use to show that lines are perpendicular. And that symbol also shows that the lines are at 90 degrees to each other, because we know that lines that are at right angles or 90 degrees to each other are perpendicular. Okay, so you want to take down this part and also this and the drawing into your copy, okay? Now, so we're also just going to have a little chat about horizontal and vertical lines. So as it says here, a line that is parallel to level ground is called a horizontal line, okay? So a line like this red line here, it's parallel to the level ground, so that is a horizontal line, okay? So something like this is horizontal, okay? When it goes that direction there, okay? And then it says a vertical line then is a line that is perpendicular to the horizontal. Okay, so if we use the information that we found out there, we know that perpendicular lines are ones that make a right angle or 90 degrees with each other. Okay, so as you can see here, this red line here is making a right angle with the floor here. Okay, so this red line here is a vertical line. Okay, so we can basically kind of say that lines that are going down are vertical lines and lines going across are horizontal lines, okay? But we have to make sure that the lines are parallel to the ground if it's a horizontal line and perpendicular to a horizontal line if it's a vertical line. Okay, so now we're going to have a look at something called axioms, okay? Some geometry axioms. And these are basically a set of rules in geometry, okay? Now, I don't want you to worry too much about these because you're going to look at them in more detail later on in your course. However, we're just going to have a little brief look at them right today, okay? So the first axiom is that there is exactly one line through any two given points, okay? So if we had a point here and a point here, there's only ever going to be one line through those points, okay? They can't have any other line through those points. So that's all that first axiom there means, okay? So it's kind of self-explanatory. So now we're going to have a look at axiom 2. And this axiom is about the properties of the distance between points, okay? So it has 4 different kind of sections here. This first section, distance can't be negative, e.g. the distance of a line segment can't be -3, okay? So we can't have any minus distances, they always have to be positive, okay? Point 2 then, the distance between AB is the same as the distance between BA, as they are the same line segment, okay? So basically, if we had a nice line segment here, so we'll say this is A, this is B, draw, okay, there's our line segment, and the distance between A to B is going to be the same as the distance B to A, okay, because they're the same line segment. Then, the third point here, if C lies on AB, in between A and B, then the distance of AB is equal to the distance of AC plus the distance of CB. So that might sound a little bit confusing, but if we think it like this, better like this. Just say AB is 10 centimeters. So this line segment here is 10 centimeters long, okay? And it says AC is 4 centimeters. So between here and here is 4, okay? We know the whole line is 10. This part's 4. 4 plus what gives us 10? 4 plus 6. So that means that CB must be 6, okay? Because this whole line is 10. And we know that as C is on this line, the distance between AC and the distance between C and B, if they are added together, has to be the same as the distance AB, okay? Then the last little point here is, on a ray, every point on the ray is a specific distance away from the end point. No 2 points are the same distance away from the end point, okay? So let's say we have a ray here, okay? It's starting at A and it's going on and on and on and on and on. Then we have a point B on this ray, okay? This point is 5 centimeters away from A, okay? And basically all they're saying is that no other point on this ray could be 5 centimeters away, okay? So if I had a point here, or I had a point here, or a point here, none of those points would be 5 centimeters away from A, okay? Because only this point here, B, is 5 centimeters away from A. Just like there's only one point that might be 3 centimeters away from A, or only one point that's 1 centimeter away from A, or 6 centimeters, or whatever. There's only one point on this ray that is a specific distance from this point A, okay? So that is basically what that final point is explaining, okay? So that on a ray, every point on the ray is a specific distance away from the endpoint, and no 2 points are the same distance away from the endpoint. Okay, so now we're going to have a look at axiom 3. And this says the properties of the degree measures of an angle. Okay, so it's basically all about angles. And then it says here the number of degrees in an angle is always a number between 0 and 360, okay? And I know that last week you learned that there was such thing as a full angle. And in the full angle, like this, the degrees is 360, okay? And we can't have more than 360 degrees, okay? So the number of degrees in an angle is always between 0 and 360. So this axiom 3, it combines the following properties. Firstly, it reminds us that a straight angle measures 180, okay? So straight angle, straight line like this, it has 180 degrees, okay? Then the second point is, if an angle is divided up into 2 smaller angles, then these 2 angles add up to the original angle, okay? So let's have a look at that in more detail in this picture here, right? So here we have this angle here. It's angle 3, we're going to call it, okay? So it's this angle here, angle 3. And then they've added this line here, BD, or this ray, should I say, BD. Okay? And with BD, we now have 2 mini angles. We have the angle 2, and we have the angle 1, okay? And all they're saying is that if you added up angle 1 and angle 2, you would get angle 3, okay? As you can see there. And that's all that one means, okay? So if an angle is divided up into 2 smaller angles, then these 2 angles add up to the original angle, Then our final axiom is axiom 5. So it says, given any line L and a point P, there is exactly one line through P that is parallel to L. Okay? So let's just say we had there in this picture here, right? There's this line L here, okay? The point P, and they're basically saying that there's only one line that they could have drawn through P that would have been parallel to L, okay? Because every other line they may have drawn through P, let's see if I can try and draw some lines here. That's not parallel. That's not parallel. That's not parallel. That's not, we could have drawn so many lines through P, okay? But they're saying there's only one line through P that is parallel to L, okay? And that's what that one means. Now, if you're not too sure about the axioms or you're getting confused, don't worry, okay? They're not that important. I just said we'd touch on them, but don't be too concerned about the axioms, okay? But you can take those down into your copies, okay? Number 1, 2, 3, and 5, and the little bits that I've written beside them, okay? Now we're going to move on to our main aim for today, which is finding missing angles. So we're going to have a look at this example. It says AB is a line shown. This is our AB line. Question A says, what type of angle is ABC? Okay, so this is going back on the work on angles that you did with Ija Reid. So we can see that ABC is less than 90, because 90 would be here. So we know that ABC is an acute angle. Okay. Then part B, it says, without using a protractor, find the measure of ABC. So they want us to find this little bit in here, okay? So we don't know what it is, so I'm just going to mark it. And as we don't know what it is, I'm going to call it X, okay? Just like in algebra, we don't know what it is, and we're going to solve it for X. Okay, so let's see, what do we know here? So we know we have a line here, okay? A line going here. And what do we know about a line? We know that a line is a straight angle, and a straight angle is 180. So we know on that line, from here to here, that's 180. Okay, so we could say straight angle. I'm going to zoom out a little bit here. Is 180. Okay, and if we have a look here, okay, if we think back to axiom 3, okay, we know that this is our full angle, okay, that's our straight angle, and we know that this angle here plus this angle here is equal to this big, 180, okay? So we can say that 130 plus x is equal to 180. Okay, now we're back to our algebra. So remember, we always want letters on one side, numbers on the other side. So let's say we want our letters on the left, okay? So we're going to have a little look there. We have a letter, but we also have a number on the left, okay? And then on the right, we just have numbers, and that's fine, because we want just numbers on the right. So the right is fine. The left, we just want letters, so we need to get rid of this 130. So I'm going to minus 130. And remember, what I do to one side, I have to do to the other side. So I'm also going to minus 130 here. So 130 minus 130 is 0. X is equal to 180 minus 130, which gives me 50 degrees, okay? Then I'm going to go back to my question. So we call the angle X, but it's actually angle ABC. So we're just going to change that. We're going to say angle ABC is equal to 50. And make sure you remember your degree sign there. Now, if you could take this example down in your copy, that would be great. Now, we're going to have a look at another question. So it says, using your knowledge of the geometry axioms, find beta, okay? And beta is basically just, it's like x. We can call it x, okay? We'll write it in as beta for now, but we could easily call that x or y. It's just a letter, okay? So let's have a look at what we know here. We have a full angle here, okay, technically. And we know that this angle here is 80, this here is 155, and we don't know what beta is. We're looking for beta. So we know that this whole thing here is 360, okay? And we know that when we divide up the angle, when you add all those bits of the angle together, you get the full angle. So we know 80 plus 155 plus beta is equal to 360, okay? Now, can I tidy that up? 80 plus 155, that's going to give me 235 plus beta is equal to 360. Now, just as before, we want our letters on one side and our numbers on the other. So, let's have a look here. We want letters on our left. I have beta, but I have a number. And then on my right hand side, I have a number. So my right is fine, but the left, I have a letter, but I want to get rid of this number. So I'm going to minus the number from both sides. So what I do to one side, I have to do to the other. Okay, so I end up with 235 minus 235 is 0. Beta is equal to 360 minus 235, which gives us 125 degrees, okay? And if we go have a look at our picture, we see here that beta is an obtuse angle, so it needs to be bigger than 90. So we got 125. So that sounds right. So I think we definitely got that question correct. And once again, if you can take this example down into your copy as well, so you can have it to look back over when you're doing some more questions.